volume, and this can lead to negative effect. And the second direction, is using data indexing and query optimization. And the fourth direction related with optimization of database structure. This approach we often use in relation databases, but in NoSQL or new SQL databases, we have not formalized apparatus for optimization database structure. Our research in our research, we consider database NoSQL, such as document databases and column families. For example, example of document databases is MongoDB. Column families databases is Cassandra. Why we consider only these two types of databases? Because in this type of databases, the objects which save in databases have very hard relationships. The input today we have more than 10 different methods which allow us to optimize the structure of databases. But today I can talk about only one method which light in basis of other method. The input data for this method is the set of properties of objects which we save in the databases. For example of these properties are fields which are in our databases and fields which are in queries. Queries which we offer run to our databases. And we save information about relationship between tables in relation databases. As output data, we have a document collection, for example, for MongoDB databases, and a collection of tables for column families databases. On this slide, you can see several formulas which we use in our method. On the next two slides, we show the method, but I think that maybe I better talk this method, illustrated this method on example and not on this slide. Example. The essential of our method is we need to create the set of fields from all tables in relation database. And I need to note that it will be very well if our relation databases were in normal form. But if, for example, our relation databases is not in normal form, then in further we have simply more iteration in this method, and this method will work more slowly. But account into that this method we use only one time for optimized structure of databases, then the decreasing speed of running this method, it's normal. The first step, we collect all field. On the second step, we create sets of fields which include in queries. The next steps, we will intersect these sets, and we will find those fields which not include not input in query, and we will create a new collection on MongoDB databases which will consist from this field. Our method, we testing our method on two types databases, MongoDB and Cassandra, and databases which had a different volume, and we use 9 testing queries. These queries differ from each other by complexity and amount of tables which include in this query tables to which query with which query related. On this slide, you can see volume. Volume was from about 25,000 records to half million records, and testing databases. Initially, relation databases consist from 5 tables, and the scheme of testing databases is on this slide. In result, after using our method, this method which I told in my presentation, we got scheme of MongoDB databases which consist from free collection without embedded documents. But this method is basis of the next method which allow to create a collection of MongoDB databases with embedded documents. you can see a different structure, MongoDB without embedded document and with embedded document on this slide. And bottom of slide, you can see a structure of Cassandra databases. On this slide, we can see diagrams of running queries, and these diagrams show that after optimize structure of MongoDB databases, the better time query have a better time to database MongoDB with embedded documents. The present approach is based on set theory, and I must note that the method work very quickly, and the method don't require the many resources, for example, of memory, and but this method can be used only databases with safe object with hard relationships. Thank you for your attention.
Right, thank you for your presentation. Does anyone have any questions for Yulia?
May I have a question? Okay, I have one question. Your approach is rather interesting, and I have a question in general. What is the speed up of your that you can reach by your?
Yes, thank you. Thank you for your questions. I think that I understand your questions, and I want to talk that the increasing of speed very hard depend from volume of databases, and very hard depend from structure of queries. For example, if query have many operation join, then we get increase about 50%. It very well. For example, if we had in relation database very simple query, for example, only select data without operation join, then we will get increasing about maybe 5–10%. But we after our research, we get, for example, that if query without operation join, but query have operation aggregate, then in MongoDB databases with optimal structure databases, we increase increasing speed. We get increasing speed only 5–10%. In other words, our method very well work only on that queries have in relation database have operation join.
Thank you very much.
Thank you. So the proposed approach looks interesting, and you're talking about 50% performance improvement. Compare it to that. My question
okay.
is, have you done time comparison on the same queries, for example, with MongoDB?
Okay. I'm sorry. I did not talk about it. We compare relation databases MySQL and compare with MongoDB and Cassandra. The structure of database, yes, relation database will MySQL. Today we finished testing on PostgreSQL. Only these two databases.
Okay, thank you. All right, so our next presentation is differential privacy for statistical data of education institutions, and authors is Ivan Tsvalov, Alexey Tsvalov, and Vladimir Korkov. So I prepared the presentation outside the conference template. I apologize, that's my fault. So give me a moment, I will start my presentation. And yeah. Everything is fine? Do you see my presentation?
Yes, we can see that.
Yeah, thank you. All right, so as part of the scientific work, differential privacy for statistical data of education institutions, we considered a relatively new mechanism designed to help protect personal data as differential privacy. Differential privacy is a way of strictly mathematical definition of possible risks in public access to sensitive data based on estimating the probabilities of possible data losses. You can build the right policy to noise publicly available statistics. So differential privacy is a collection of methods based on noise of output data through randomization and randomness. The general idea behind this mechanism is that the information should be distributed regardless of whether the user of the information is an adversary or not. It's worth noting immediately that this is not some specific process, but rather a property that the process can have. The differential privacy property ensures that the result of statistical analysis of two sets of output data from the one algorithm will be almost similar, regardless of whether there is data of an individual in the set or not. Visually, this property can be represented on the slide. Database D1 and D2 differ by one line. So the architecture of systems for differential privacy needs to be provide both privacy and security. Privacy mechanisms control what can be excluded from the data we release. Security refers to controlling who is allowed to access the database, but makes no guarantees about what can be extracted from the database. To date, there are two main architectural solutions for differential privacy: central and local models. The central privacy model is the most popular system. The data is stored centrally, and each result computed on the database is differentially private by adding noise to query results. Each user on this system can send any data without any additional noise. An alternative approach is the local model, where the data curator never operates the sensitive data, so does not need to be trusted. With currently implemented system based on local model, data is individually noised before being stored on the central untrusted server. As part of this article, we considered only the central model of differential privacy. Let's consider an analysis on database containing personal information about students. The analysis may be as simple as determining the average age of students in the data, or it may be more sophisticated and involves performing for some computation on data and outputting the result. For example, consider counting queries to compute the number of objects that have some property. Say, how many students live in dormitory in the first 99 records. Doing the same with the first 100 records and determining the increase in result by one adversary can definitely find out that 100 records contain information about the dorm's residents. If the adversary has access to information on the 100th record, that the student came from the Kemerovo region, for example, then in a certain case, identification will happen almost instantly, because there may be a single student from Kemerovo region in database. That is, the organization of the process of issuing statistical data requires careful planning and determining and limiting the set of data that should be issued in response to requests. So let's determine that the interaction between the analyst and the DP mechanism occurs through some kind of transformation or transcript. First of all, it's quite enough to consider the transcript as a single request to the database and the response to this request. Roughly speaking, a non-interactive mechanism M is differentially private if for any transcript and for any two sets of database Y and Y1 differing by one entry. The probability of obtaining result differ by 1 plus epsilon times for sufficiently small epsilon. It's technically more convenient to use exponent instead of 1 plus epsilon, because the former behaves more nicely under multiplication. The mechanism is most often chosen based on the probability density distribution, such as Laplace or Gauss. We will consider the Laplace distribution, although this is not mandatory. It's clear that using continuous distribution as a mechanism can significantly reduce the performance of the program. So we should use a sample of discrete distribution. The most suitable method of generating random variables is based on the generic procedure called the inverse sampling method. In our case, we know the probability distribution function for the Laplace distribution. Thus, having random variables in the range from 0 to 1 and an inverse function at the input, one can obtain a discrete distribution. This computing results in the procedure for sampling for the exponential distribution with parameter lambda. Such similar transformations have already been implemented in the form of library functions for any popular programming languages. In fact, the privacy budget determines how many statistical queries can be made to the entire system and how accurate the result will be. In this case, it's necessary to maintain a balance. By setting the value too high, confident data will leak. By setting it too low, the accuracy of data will quickly tend to zero. Based on this, in many cases, the privacy budget is obtained empirically. A simple composition of differential privacy algorithm is differentially private, and the final value of epsilon is the sum of coefficient of epsilon for each individual algorithm. However, such an approach is not without drawbacks related to the very nature of such a strict approach to differential privacy, when probabilities in the range minus epsilon to epsilon are considered. That is, tails are lost. To weaken such a condition, the concept of epsilon delta differential privacy is introduced when the added coefficient delta makes sense to correct the situation in an emergency situation when the strict condition of differential privacy is violated. The strategy of spending the privacy budget can be implemented by adding an immediate service with the calculation, accumulation, and accounting the current budget. Final implementation are not longer so obvious and requires a lot of effort from developers. The implementation of the DP can be described in the form of the dependent model, which will be an addition on the software product that distributes statistics. Architecturally, the differential private model can be divided into two services. First of all, it's privacy service and budget spending service. The privacy service acts as a coordinator or instructor who receives the request, process, and returns the response. The most important in this model is the budget spending service, which stores the current state of the budget, calculates the new value, and regulates access to the data based on the established privacy restrictions. In fact, the implementation of such a service is the main and the most labor-intensive part of building the general architecture of differential privacy. It's worth noting that budget spending implies the use of certain starting budget value, which can be calculated from the bottom up, starting from the simplest components of the system. Such an architecture solution is not standard, but clearly demonstrates the direction of future work in study of differential privacy by the community. So that's all on my part. Thank you for your attention. So, anyone have a question for me?
Ivan, may I have a question? Are you hearing me?
Yeah.
The question is very simple and maybe rather stupid, because for my, as I know the distribution of Laplace, it is a symmetrical distribution, and it is looks like some mixing of Gaussian distribution in exponential asymptotics. But in this case that you present, for my mind, it is not a symmetrical distribution. It is not a symmetrical nature of this data. Why Laplacian distribution here is applied?
So I can answer that Laplace distribution is the most simplest way to demonstrate how differential privacy, what is differential privacy. Actually, we can use any.
Okay.
Any distribution, what you want. But Laplace distribution is good for demonstrate how this service should be worked. So I guess.
Because why, in this case, why not a normal Gaussian distribution? Because Laplacian, it is some mixing of Gaussian distribution with zero mean.
Actually, we use Gaussian distribution as well. So we provide information in our article, and it is.
Okay, thank you.
Okay, thank you. So, all right, our last presentation is a systematic literature review on numerical weather prediction models and Provenance data. Authors Alper Turek and Mehmet Aktas. So let's start.
Okay, can you hear me?
Yes.
Let me first start screen sharing.
Yeah, sure.
entire screen. Okay, share. Can you see my screen?
Yes.
Okay.
Yes.
This is full screen. Is there a problem? I think there is no problem.
It's all okay. It's all okay here.
Okay. Hello, everyone. My name is Alper. I'm joining from Turkey to present my work of a review on numerical weather prediction models and provenance data. I am a PhD student at Yıldız Technical University in Istanbul. As you may already have realized from the paper title, this is a systematic review study where we specifically focus on primary studies that either directly suggest an organized provenance infrastructure for numerical weather prediction workflows, or at least implement a case study on a numerical weather prediction model, even if they consider a broader scope. With primary study, we mean an experimental-based study that investigates a specific research question in any field, whereas a secondary study is one in which all primary studies related to a specific research question are reviewed and the findings are compiled and synthesized. Our main motivation is the fact that, like many other scientific software, numerical weather prediction model software is developed by scientists within their own disciplines in general. As such, these software do not have an integrated ability to automatically generate and store a structured provenance record. In this respect, there is not much provenance research directly related to numerical weather prediction systems. Numerical weather prediction is the process of using mathematical models to simulate the physical laws of the atmosphere and oceans in order to forecast the weather based on the latest weather conditions. The calculations often take hours to complete, depending on the input parameters like grid resolution or forecast period and the size of the forecast domain like regional versus global. Considering the effects of meteorological events such as floods, hurricanes, hailstorms, winds, etc., a small improvement in prediction accuracy or in computation speed as well as in reaction time becomes crucial in weather prediction. This requires scientists or researchers to work in cooperation and share their data and results with each other. In this respect, provenance plays a critical role. According to the World Wide Web Consortium, provenance is the information about entities, activities, and people involved in producing a piece of data or anything which can be used to inform assessments about its quality, reliability, or trustworthiness. We think that this review study will shed light on the current state of the literature on the subject and increase the interest in the topic. To the best of our knowledge, this kind of a systematic review study on both numerical weather prediction models and provenance research doesn't exist. The first step in a review study is to define the scope and determine the research questions beforehand. As I mentioned earlier, we focused on primary studies that directly suggest a provenance infrastructure or at least implement a case study for numerical weather prediction models. We restricted the publication years between 2012 and 2021, spanning the last decade. The reason we chose 2012 as the starting year is that it is the year when the first working draft of the ProV family of documents was published by World Wide Web Consortium. After defining the scope, we determined 5 research questions that can be seen in this slide. The first question is, what provenance standards or specifications are used? Another question is, what are the provenance sources used? In other words, from where provenance is obtained. The third question is, what provenance storage mechanisms are proposed? The fourth question is, what is the distribution of publications by year? The aim in this question is to see, is there any visible trend on the topic? And the last question is, in which journals or conferences have related papers been published? This is to identify journals and conferences where researchers publish or present their studies on the topic. In this review, our target studies are research articles or short papers written in English language. A study must focus on provenance data in numerical weather prediction workflows, or at least implement a case study for a prediction model to be considered as relevant. We excluded duplicated and non-English papers and secondary studies like surveys and reviews, book chapters, tutorials, technical reports, etc. As I said in the previous slide, we restricted the publication years between 2012 and 2021. To find the relevant primary studies, we performed queries in 6 most well-known digital libraries. These are ACM Digital Library, IEEE Explore, Scopus, Springer Link, ScienceDirect, and Web of Science. Each library has its own search engine and with its own characteristics. We try to be as much inclusive as possible when constructing query strings. Numerical weather prediction sometimes may be referred to as atmospheric modeling or numerical weather forecasting. If supported by the search engine of the data source, we used wildcards to include every different form of keywords. Otherwise, we exclusively included most possible variations of keywords in query strings. In the reviewing process, we use 2 software tools, STArt and JabRef. STArt, which is short for state-of-the-art in systematic review, is a free tool that aids performing review studies in a formal way. With the STArt, it is possible to list all primary sources together and to easily classify them as accepted or rejected by quickly evaluating titles, keywords, and abstracts if available. Its ability to detect duplicate papers and the support for performing the selection and extraction phases separately and sequentially reduces the risk of error in the execution of the systematic review process. JabRef, which is another free tool, is a reference management application that can import more than 15 reference formats, and it supports many operations such as merge, convert, and export. In this slide, you can see the summary of search results and the number of obtained papers at each stage. We obtained a total of 3,759 results when we performed a search on all search engines with the constraint of publication year between 2012 and 2021. After applying the exclusion criteria, we get 2,176 results left. Duplicate papers, surveys, review articles, book chapters, posters, tutorials, and the like are removed in this stage. In the next step, shown as phase 1 in the diagram, we have read titles, keywords, and abstracts, and we eliminated irrelevant articles. At the end of this stage, we have 318 studies left. At the last stage, we examined all the remaining articles in depth, and we identified 16 relevant papers. We synthesized the findings obtained in line with the research questions. I will share these findings in the following slides, a separate slide for each research question. With regards the research question 1, in most of the relevant studies, Open Provenance model and its improved version, ProV specification, are used. However, some studies use a provenance format of their own, while some other studies use various known but less commonly used provenance formats. For example, while in one study ecological metadata language EML is used, in another study web ontology language OVAL is selected for provenance representation. The OVAL languages are characterized by formal semantics, and they are built upon the World Wide Web Consortium's standard for objects called the Resource Description Framework, RDF. In one study, 2 extension schemas of ProVo specification were developed, one for file-oriented provenance and one for streaming data provenance. In 5 out of 16 studies, no known provenance format is specified. The provenance sources which are used or proposed in the selected primary studies can be shown in this slide. It is possible to use a variety of sources to obtain structured provenance. Scientific software is often run in a certain order according to a defined workflow through a workflow manager. Therefore, the most common source of provenance is the tracks that workflow management software keeps while running tasks within the workflow. However, in this method, there may be provenance losses for intermediate processes of an atomic program in the workflow. Another important source of provenance is the log files created directly by the scientific software itself. In this method, it is possible to capture the details of intermediate transactions, but on the other hand, the fact that there is not a common standard for log file formats brings additional difficulties. Another method is the instrumentation of the source code of the software so that the application itself generates structured provenance directly at runtime. There was no study in this group which uses direct instrumentation of the source code. Each method has its own advantages and disadvantages. For example, in the source code instrumentation method, no intermediate extractor will be needed, but it is not always possible to find the source code of the software. Even if the source code is available, making additional changes to the code needs recompilation and may cause the program to exhibit ambiguous behavior or introduce bugs. The provenance storage mechanisms which are proposed and used in relevant studies are summarized in this slide. The most well-known system developed specifically for organized provenance storage is called KARMA. Komadu, which is another specialized provenance system, is an advanced version of KARMA. While KARMA supports the Open Provenance Model standard, Komadu fully supports Provi specification. Apart from these two systems, some studies directly use a relational database system like MySQL or Berkeley DB. While some studies do not give details about the provenance storage environment, in one study, the Kepler Workflow Manager was extended to add provenance support. When we look at the final extraction results, we can say that there are not much primary studies that get into the scope, considering 16 final relevant papers. Although there are many primary studies in numerical weather prediction domain, there are not many studies combining this with the concept of systematic provenance. Systematic provenance is mostly research in the field of software engineering. If we look at the publication years, we can see that although there is no general pattern in the distribution across years, it is possible to say that there has been a relative increase in the number of studies on the subject as of 2021. Lastly, in this slide, we list the journals or conferences in which relevant studies are published or presented. Since the total number of relevant studies is small, it is reasonable that there is not a clustering on a single journal or conference as expected. Only one paper per journal or conference has been published or presented across all journals and conferences, except for the Future Generation Computer Systems Journal, where a total of 3 different studies have been published in the Future Generation Computer Systems Journal. Another fact that can be seen from the list is that most of the journals or conferences are related to computer or software engineering disciplines. And that is all for now. Thank you for listening. If there is any question, I'd like to try to answer.
All right. Thank you for your presentation. You have done a great job. The statistics are amazing. Does anyone have questions?
Okay.
Yes, I have a question. May I ask?
Okay, I'm listening.
Okay. The question is on. I know that in the field that you have considered, there are some stable teams who develop different models in this direction. And of course, they publish their papers in different journals, publish house, and so on. Did you consider formation of such teams from the authors, because they can not on one author and not in just only in some key words in the articles, and it would be very interesting if you separate all articles on such teams. Did you have such attempt or no?
No, we did not make a query on the teams, both for numerical weather prediction model developers or paper authors, I mean. But I can say that most of the primary study authors are from software engineering discipline. As I said in the slides, this topic is researched in software engineering mostly, and scientific software.
Just on research, okay.
Okay. Yeah, I mean, scientific software developers are usually scientists from their discipline, so they don't consider provenance perspective when developing.
Okay, thank you.
You're welcome.
Thank you. I guess that's all. Thank you everyone for reports and for questions.
Thank you. Have a nice day.
Have a nice day. Bye.
Bye. Thank you. Are you going to stay here in the room or no? Are you we are moving to the HL. Okay. Okay, so I'm going to take a coffee. That's why I don't know if I bring my bag or.
Hola, ¿qué tal? Hola, tío, ¿qué tal? Tío.
Вот. Оп, да? Ну да, смотри. Что?
Hello, everybody. I'm the chair of this session, Scientific Computing Infrastructure. I think in a minute we'll start. Okay, we shall start. The first presentation is Smart Habitat. Features of building it infrastructure. Main problems of building data networks using 5G, 6G technologies. The authors Alexander Bogdan, Надежда Щелкова, Геннадий Дик, Валерий Хватов, and Alexander Dick. I think Alexander Dick will be the presenter. Am I mistaken?
Gennady, as I understand, you will present.
Well, I understand. Let's start.
Yes, please.
Dear colleagues, at this conference, I would like to introduce you an article.
Share your presentation, please.
A presentation, okay. Да что тебе? Включи демонстрацию экрана. Где у нас вот? Слышно нет?
Слышно, но...
Слышно и видно вас только.
А презентацию?
Нет.
Нет, презентацию не...
Alexander Degtyaryov, I think you want to have some speech, please. You're welcome.
No. I switch. It's by mistake.
Okay.
And now you can
Yes,
see.
we see. Yes, we see.
Yes.
Okay. Dear colleagues, at this conference, I'd like to introduce you an article, Smart Habitat, Futures of Building IT Infrastructure, Main Problems of Building Data Transmission Network Using 5G, 6G Technologies. The main issues of this article are as follows. First, development smart habitat fragmented technology. Second, development smart habitat information transmission network for SHV. Third, networks of the 5G and 6G standard. Fourth, security problems and possible risks of 5G and 6G networks. And fifth, levels of protection 5G or 6G networks. One of the significant factors in improving of quality of the life of the population in modern conditions is the use of the so-called smart home technology, which for the purpose of further development develops into a whole strategic direction of building the infrastructure of the habitat called smart habitat. As you know, these technologies have some advantages. The well-known technology, smart home and then smart city, has long been used in the modern world, but at the same time, the aspect of introducing these technologies in small summer cottages and villages is out interest, increasing interest. And now, is proposed on developing the problem of chosen information transmission network to form the most effective version of the IT infrastructure, while paying special attention to the issue of analyzing the architecture of building networks of the 5G standard in the future 6G and the security threat landscape directly related to it. Practice shows that if there is a fairly developed switching infrastructure in the city limits, then in settlements outside the city is practically absent. Thus, there is a need to faster and broadband communication channels with wireless properties, because the introduction of SHV technology is not always and not everywhere possible to organize a wide cable. To resolve this issue, 5G and 6G wireless network are expected to provide global coverage of the surface on the NTS, so that the user and connected can access the internet anywhere and at any time. In this case, wireless terrestrial networks must be combined with air and water access nodes, satellites, drones, high-altitude platforms, surface signals, broadcast stations, etc. The seamless 3D land, sea, and sky coverage constructed in this way will form a global integrated communication network. Thus, all terrestrial and non-terrestrial networks will be comprehensively integrated at the system level, providing conventions of service, wireless interfaces, various types, and networks are connected user devices. In the contrast to the smart habitat concept, one of the main tasks for creating complex social-technical systems is to build an IT infrastructure with distributed communication support disks. These disks should include a complex of information system consisting of local automation equipment using artificial intelligence technology, sensors, video cameras, etc., and mega-cognitive control technologies, complex social cyber physical system based on a neural network, as well as high-performance wireless data network. It is a set of different devices and sensors united by wide and wireless communication channels and lightly connected to the internet to better integrate the real and virtual world, when in fact communication is carried out between people and devices. It's assumed that with the development of a technology will become active participants in business, information, and social processes, where they will be able to interact and communicate with each other, exchanging information about the environment, reaction, and influencing process occurring in the world around them, without human intervention. Thus, it can be assumed that this construction is a self-organizing network of many sensors interconnected via a radio channel. Moreover, the coverage area of such a distributed wireless sensor network can range from several meters to several kilometers, due to the ability to relay messages from one element to another. The main advantages and disadvantages of building of an ITN based on Bluetooth, Zigbee, Z-Wave, NFC, RFID, Wi-Fi, LTE were widely illuminated in various sources. As for network of remote range, that is cellular, then the introduction of networks of the fifth G and then the Provenance 6th generation, in contrast to the LTE network, will significantly expand the ATN, taking into account three main scenarios for its, and namely, first, enhanced mobile broadband application, 4K, 8K, 3D live streaming, and virtual reality services, cloud gaming, and other high-traffic services. Second, ultra-reliable and low latency communication application, unmanned vehicles, vehicle to everything, remote technology, automation of production lines, robotic surgery, and etc. And such, machine-to-machine communication, application, development of customer and industrial edge, power supply, manufacturing, smart city. Despite the position of the fifth and sixth generation ITNs as secure, the analysis below shows several security problems. First, significantly increased attack surface. The circumstance is primarily due to the ever-increasing number of edges, which in turn leads to a proportional increase in entry points for organizing target attacks. As a result, many connections and high bandwidth increase the attack surface, while the number of each devices that are less resistant to hacking is growing. Second, the architecture of the core network is based on cloud technology and virtualization of network functions, software-defined network. It's allowing to create many independent segments and thus support services with a different set of characteristics. In addition, shuttling will allow operators to provide network infrastructure as a separate services. Thus, the risks should include the fact that such a construction of a network infrastructure leads to more serious consequences in case of failures and cyber attacks, considering the scale of use. And such, ample opportunities are open for more aggressive conduct of various types of so-called espionage. As you know, any devices with the ability to capture video and audio information can be used by cyber criminals or software hardware manufacturers to view and listen to uninformed users. In this case, the risks are obvious. Fourth, an analysis conducted by the International Team of Security Research from Purdue University in Iowa State University found almost a dozen vulnerabilities in the fifth generation mobile communication standard. In this case, the risks include attacks such as monitoring the activity of subscribers, which, in addition to physical tracking of the subscriber of such devices, create prerequisites for the security of encryption protocols. Fifth, 5G networks and then 6G involve the active use of edge computing technology. This can be corporate applications running on the network of operators, intelligence services, financial services, multimedia. It should be added that in this case, the operators 5G and 6G networks are being integrated into the corporate infrastructure. Thus, the risks include new opportunities to penetrate corporate networks, the placement of MAC equipment outside the protected perimeter of the organization, as well as the fact that the speed of a malicious attack becomes significantly higher. And 6. The centralized network management infrastructure used in 5G and the 6G networks is complicated by the need to simultaneously support a large number of service segments. In this case, risks can be attributed to more serious consequences of misuse or resources and or operation maintenance and configuration errors. Based on the analysis of possible security problems of 5G and 6G networks, is proposed to define several levels of protection. The first level is protection at the level of implementation of technical solution building the network infrastructure and equipment distributed options. And namely, first, the use of powerful between users and the outside world, multi-level isolation and protection of the integrity, the hypervisor, virtual machines, operation system, controllers, and containers. Second, authentication of Mac application use an additional authentication factor when accessing the corporate network. Whitelisting of devices and services, authorization of IP requires, and others. The second level is protected at the level of network infrastructure management, such as first, secure management is not only user data, but services, technical, analytical, and other type of information involved in ensuring the solution of SHF task is so-called attack on the subscriber and attack on the mobile operator using encryption, anonymization, depersonalization, etc. Second, centralized management of identification vulnerabilities as well as policies and level of information security, and others. And now the third level is protection at the level of the standard. Such as separation of the layers of the protocol for receiving and transmitting data in the three planes: user plane, control plane, manager plane, with complete isolation, encryption, and integrity control of these planes. Second, use of encryption methods for subscriber and technological traffic with an increase in the length of the encryption key. Third, the use of a single mechanism for subscriber authentication for various types of wireless communication. I just said at the same time, it should be noted that in addition to ensuring information security at all levels.
Sorry, Gennady, you have only 5 minutes for both, for finishing your presentation and questions. Take care, please.
It's my finish. A comprehensive approach is need to protect network of 5G and 6G standard, which includes an administrative technical approach from ongoing network audit to continuous environment of security system. Thank you for your generous attention.
Okay, thank you for your interesting presentation. Please,
So
questions.
lovely. Выключиться тогда.
Gennady, don't speak Russian, please. Okay, questions. No questions, then maybe I will have one. Gennady, how you see the practical implementation of your research? What will be the next step? Gennady, do you hear me?
Listen.
Okay. How do you see the future research in this direction? And practical implementation of your research?
I hear so badly. Can you speak loudly?
How do you see practical
Sorry.
implementation.
In practice,
Yes.
Can you repeat your question? Maybe some loudly.
Окей, может быть, по-русски я спрошу. А как вы
Да,
видите практическое применение своих исследований?
I think it's only my theoretic research, because now the 5G and 6G networks не представлены на нашем рынке.
Are not represented on our market.
Does not present our market. Yeah.
Yes.
Yeah. Thank you, Alexander Boris.
Okay, thank you. Do you hear me? Okay, thank you very much for your presentation. So the next one. Yes, the authors Даниил Маливанный, Олег Якушкин, Владимир Корхов. The name of the presentation: large-scale network simulation for testing distributed applications. Who will be the speaker? Daniel, I think you.
Yeah, I will present our
The floor is
presentation.
yours, please.
Yeah, give me a second. Does the screen share work? Okay.
No, we don't see your presentation.
There is a problem with my browser.
We will wait. We have 1 minute still. So.
Okay. Can you hear?
Okay.
Can you
Wonderful.
see it now?
Okay.
Nice. And if I do it like that,
okay.
Can you still see it?
Yes, we see. Start, please.
Yeah. Today I will be presenting our work of more than 2 years. L3NS is a library that aimed at providing a simple-to-use and versatile simulation of large networks, giving developers a bird's-eye view of what happenings with the distributed application in different network scenarios. And as I was saying, L3NS is a library. It's a Python library. The full name is Layer 3 Network Simulator. We choose a Layer 3 since it's just right amount of abstraction for most applications. And our main focus is at simulating large networks. Our current results show that we can simulate networks up to 10,000 nodes in a given appropriate computational power. And as our research shows, there is no hard limit on how exactly how high can you scale the simulation process, since the overall architecture is quite simple, and most of the resources is provided by the simulation hosts. Currently, we're using Docker as a containerization platform, and for most of our networking setup. And L3NS is shipped as a Python library that allows user to define network topology using simple code, and then launch a model using different kinds of resources. Library implements automatic IP management and a high degree of automation of dynamic routing management, and also NAT for cases when the local networks might be of interest for developer. Other interesting features include the possibility of dynamic changes in different parts of the network that is implemented via TC utility. and also, of course, the possibility of distributed simulation for resource-intensive apps, for example, blockchains or something like that. Here we can see an overview of L3NS architecture. We got on the right side the core of the library, namely the L3NS Python API, and several tools that I mentioned earlier that is used to provide most of the functionality, and also the toolset for a developer. And on the left side, we have a simulation part of the library that can be swapped for another one, providing different providing the possibility to use different kind of the resources for different cases. Currently, we provide only Docker, but we working on using native Linux containers to lower the limitations of our library. So yeah, we're trying to not stick to one kind of containerization or even a virtualization platform, but to save the possibility of using different ones and see what works in which cases. Here we can see a simple example of the L3NS API. Here we create two routers. They are ordinary nodes of the network that are connected with subnet. Later, we set up an OSPF dynamic routing protocol between them and connect one node to each one of them, making the whole network being able to share traffic between nodes. And we also can pass different information about one node to another one. In this example, we're using that feature to start a Kademlia DHT protocol inside our simple small virtual network. We are using Kademlia in most of our examples since it's fairly easy to use and fairly straightforward distributed application that still can adapt to a different networking situation. And yeah, it's a good example to demonstrate the features of the L3NS library. As I was saying earlier, we are providing a possibility for distributed simulation. We are implemented it using Docker VXLAN support. VXLAN is a protocol that allows different computers, for computers that are situated in different physical subnets of the global internet, to create a local private subnet that will connect them directly. And all of that happens transparent as far as networking layer go. And we also solved a problem of automatically distributing load during distributed simulation using hypergraph partitioning protocol. We also provide some research on the limitations of our chosen way of simulating computer nodes in the network. And the main thing that we wanted to see is what is the maximum amount of nodes that we can realistically simulate. And the easiest way to see that is to try to understand how the computational resources required are changing with the changing number of nodes in the virtual network. We ran two set of tests. First set in the local simulation when we are using just one node for simulation, and the second case was distributed simulation between two nodes that both were situated in Amazon AWS cloud. In first case, there are there were three features that we were trying to get data on. First of all, it's RAM usage, it's CPU load, both for user space and user space and system CPU usage. And that should give us a brief overview on how the L3NS consumes computational resources. So the first feature is RAM usage. As you can see on these figures, it rises fairly linearly with a rising number of nodes, and there are no signs of any hard limitations seen on this fairly small but still already useful number of nodes. However, there is a problem. It's most likely tied with Docker, that even after the module is stopped working, and after everything with L3NS is done, we are still seeing some RAM usage on idle. So not all of RAM being vacated after the network has finished work. It probably has to do with how Docker manages its memory, and we are trying to see how different containerization platforms will behave in this case. Second feature set is user space, CPU usage, and system CPU usage. We are looking at CPU usage separately for different spaces, because user space is mostly used by the application that is running inside the container, and system CPU usage is mostly tied to working with network packets that being passed between containers. So both of them rising steadily with a rising number of nodes. As you can probably see, the system CPU usage is a lot lower than user space CPU usage. So even for large models, the application will still consume a lot of more CPU resources than the simulation itself. And here we can see an overview of all of three figures compared directly to each other for fixed amount of nodes. I think in this case it's 300 nodes. We once again can see that not all of memory is being vacated after simulation was finished. However, there are not such problem for CPU load. Idle is empty for both cases. And moving along to distributed simulation, we can see the same case here. We are seeing a steadily rise of both RAM CPUs, but both RAM and CPU usage. That is shows no hard limit on how many nodes we can simulate given appropriate resources. And what's more interesting, we're using a relay node to connect all of the node that will be used for simulation. And as we can see, the CPU load and RAM usage is not rising at all with the rising amount of nodes. So relay node is used only for the initial connection and doesn't really participate in the work of the simulation itself. That's a very good sign, and yeah, we are trying to see how much nodes we can simulate in practical tasks. Our future plans involve, as said earlier, introduction of different containerization platforms, and also further tests and trials of L3NS library in more practical examples. Thank you for your attention. I can answer your questions now.
Thank you, Daniil. Please ask your questions. Daniil, sorry. Can you tell me maybe once more what are the main conclusions of your research? Maybe first.
The main yes, sure. The main conclusion of my research is that when using our combination of simulation techniques for network simulation, we see no hard limitation of how many nodes can be simulated given appropriate resources. I think that's the best takeaway from our research. Basically, you can use containers to simulate any given a network of any given scale.
Okay, thank you. You have no special slide for conclusions, so I ask.
Oh yeah.
Take care in future. Okay, thank you. Any other questions? No questions, then thank you once more, Daniil. And we will go to the next presentation. The authors are Alexander Vadyaha, Alexey Subotin, Natalia Zhukova, Елена Stankova, and Michael Chervontsev. The name of the presentation is Use of Digital Twins and Digital Threads for Subway Infrastructure Monitoring. I think Alexey will present this, yes?
Hello, I am presenter. Can you hear me?
Yes, we hear and we see your presentation. Everything is okay. Start, please.
Good afternoon, ladies and gentlemen. We present to your attention a report on the topic use of digital twins and digital trends for subway infrastructure monitoring. My name is Alexey Subotin. I am a postgraduate student of St. Petersburg State Electrotechnical University. My presentation is founded by a grant from the Russian Academy of Science. Next slide. Digital transformation. Currently, digital transformation is the main trend of the modern business development. Digital transformation are the main division forces of digitalization as they are way of doing business. Digital technologies provide three main opportunities of changing business. First point is Ubuntu's data distributions. Next point, unlimited connectivity. And last point, huge computing power. Next slide. Analysis of currently state relevance. First point, advanced is the field of nanotechnology, telecommunications, and software engineering have made it possible to reach new levels of completely in the systems being created. Next point, the complexity of the systems being created is largely due to the number of levels of hierarchy and the levels of intelligence. Constantly increasing the level of structural dynamics and the use of dynamic business processes. Next point, the range of technologies and platforms available to the developer is expanding. And last point, the emergence of new paradigms such as the Internet of Things, Industrial Internet of Things, and more. Next point. Next slide. Model-based approach, which are widely used in system design, can be considered as such approaches. In particular, in recent years, approaches to building systems based on the use of digital twins and digital trends have been widely used. DT and DTH can be considered both as implementations of a model-based approach and as visualization mechanism. Can we on this slide? Next slide. Digital twins and digital trends. There are a number of definitions of the concept of deity. The most general definition of deity, according to ISO, is the following. A digital twin is a virtual representation of real-world entities and processing synchronized at a specified frequency and fidelity. Next slide. Use of deity. One can define the following typical approaches to the use of deity. First, controller of a physical entity. Next, intelligent controller of physical entity. Next point is simplified model of the observed system. Next point is a full functional analog of the OBC. And last point is the access port of other systems, in particular physical systems. Next slide. Three-level model of a continuous agile architecture we can see on this table. What do we offer? Our approach. We launch a scalable CPS can be described with the help of three-level models. The proposed model described the LC in terms of a continuous agile architecture in 5 life cycle stages and 3 levels. Next slide. And more at the top level, the OBC is described in terms of a LC of a continuous architecture. And next point is at the model level, middle level, the system architecture, and lower level, its structural and functional models are used to describe the functioning of the system. We can see on this slide in this bottom, left, right, and center. Next slide. Data collection virtual machine. We can see on this slide log requirements, log processor, script and policy processor, model processor, DSL processor, and digital twin program. We can see on next slide. Algorithm for keeping the model up to date. We think about this algorithm. First point is launching the monitoring procedure. Next point, representation of logs. Next point is cleaning and sorting logs. Next point, if correction of the model is required, then continue or revise to go step 2. And last step is correction of the model and transition to step 2. Next slide. Algorithm for processing using requirements. First step is waiting for a request from the user. Next step is receiving a request and transforming model query to language. Next step is request to the model of model query to language. Next step, if the answer is not required, then continue or revise model query to language and go to step first. Next step, policy definition. Next step is synchronizes of the script, next step execution of the script, next step construction of the requires OBC model and requires for a new model, and last step is model query language and transition to item ID. Case study. P-usage of the suggested approach can be illustrated on the example of a subway station, which can be considered as an element of smart city ecosystem. I work in subway and teach students. Next slide, explanation. The functional model for the DT for a subway station is shown in figure on last slide. The operators are presented as ovals. The arcs when connect to a vertical define the conditions for their execution. The model assumed that first the data is received when its type is determined. Depending on the type of data, video, audio, and sensors, we have only three types of data with model. Further information processing takes place. The video is divided into frames when a series of frames is processing in a full computing environments or cloud using machine learning algorithms for identifying objects on the images. The audio is also divided into frames and processing by machine learning algorithms. And additional steps are sensors. We can see on this slide is initially defined as either analog or discrete. If the sensors are discrete, then the events would are on the subway stations and can see bottom on this slide. Next slide. The algorithm for building the IT of a subway station contains the following steps. First step, determine the type of the received data, video, audio, sensors. Next step, if this is video streams, then division into frames. We can see on this slide. Next step, if this data from the sensors, then determine the type of the sensors, discrete or analog. Next step, if this audio stream, then division into frames based on the meridian loss, packaging, and more. Next slide, next point, determination of object based on series of video frames using machine learning. And next point, determination of events based on audio frames using machine learning. Seventh step is determination of events based on data from sensors. And more we can see on the bottom of the slide. Next slide. Functional model of a subway station monitoring. We can see on this slide software restart, receiving data from database, main form, building the initial digital twin. Next, average of objects from which information is obtained. Events, getting information about events, help determine of the degree of danger of the events, normally or danger, and transformer of information to the approachable service, and help information formatting of logs and reporting statistics saved to the events database. If mistakes update the information about the hardware failures, reform digital twin. fits all. Next slide. Explanation. It's last slide. The steps of the algorithm of the subway station monitoring are the following. First, receive data from the database, building the initial digital twins that contains data about all objects of the station. In next steps, we can see on this slide and read this my article. The main window of the program that implements digital twins of a subway station. We can see on this slide main menu, digital twins, and additional buttons. Next slide. Event identification accuracy. Event handing on the edge of the platform and more, average 10% and more. Next slide. Consultations. In the course of the study, three-level models of a continuous agile architecture was developed. The use of this model allows to describe all system LC stages. The article presents the use of dynamic data for solving the problem of monitoring system development. The suggested approach was used for solving the problem of monitoring of the states of the subway stations using free information sources, for example, cameras, sounds, and sensors. It's free sources only. The research materials are recordings of video, sounds, and signals from sensors obtained at the subway station. This problem can be considered as a typical problem of smart city management. The program for digital twins building has been developed at measurements of its reference were carried out, which solved an increase in the accuracy of determined events by an average of 10 more %. The usage of digital twin has shown to be effective for solving the problems of the subway, but it can be applied in more complex cases, in particular at plants, factories, bridges, and other complex structures. I work at subway and teach students. Thanks for attention.
Thank you, Alexey, for your interesting presentation. So we have plenty time for questions. Who will ask?
Okay. May I ask a question?
Please, Alexander.
I have some questions. The first one is, in your report, you focused on subway. And my question, how the specific of subway are influence on your type of your algorithms, your approach, and so on?
Yes, with good questions. We used algorithms in a fog environment. It's my time of my postgraduate student work, and I am working with new algorithm in fog environment.
I mean that is it possible to apply your approach to the other transportation? Looks like a railway for ground cars, lorries, buses, trolleybuses, and so on, or your algorithms specific, especially for the subway?
Specific of algorithm is free sources for analysis is cameras, sounds, and sensors.
So it's possible to generalize it to the other fields. Really?
I think yes.
Yes, thank you. And another question is, have I enough time?
Yes, yes, you
Okay.
can have plenty time. 6 minutes.
Okay. Another question. I found in your presentation that you use full HD video, and it is rather hard for network, and is it necessary to have so high resolution for your algorithms and for your purposes? Before?
Yes, it's
Yes,
good
here.
question.
It is, of course, I understand that it is now looks like a standard, but for these purposes, especially if you have a lot of cameras, and in this case, video stream will very hard. Is it really necessary have such high resolution or not? Or it is just because you have had such sensors?
We use it new resolution 1920 or 1080 pixels. I
Sorry,
little know English. I don't
Alexander,
full
maybe you
understand.
will translate into Russian. I think the participants hear your question in English, so you can translate in Russian, and we will translate the answer of Alexei. Насколько я поняла, твой вопрос был о том, надо ли такое разрешение высокое использовать, Алексей? Это обязательно?
Да, конечно. Для этого, собственно говоря, мы использовали туманные вычислительные среды, которые позволяют достичь более высокой точности. Соответственно, благодаря применению высокого разрешения мы уже получаем более точный результат. И, соответственно, применяем уже более высокопроизводительную систему.
Allow me to add
Okay.
to add a comment as a
Yes,
co-author.
please, Alexander Ivanovich, please. Is it you,
The
Alexander
main
Ivanovich?
idea that we don't develop the system. We only make the model of the system. It's a given solution. We must use it, and there are a lot of different stakeholder operators. Because of it, we must generate the model and no more. We use it, and we are able to work with such high resolution. It was the
Thank you, Alexander Ivanovich. I understand. Yeah.
Thank you. Okay, thank you very much, Alexei and Alexander Ivanovich and Alexander Degtyaryov. So we will go further, and the last presentation of our session is named Virtual Testbed, Computational Component of Wind Waves Ship Interaction. The authors are Alexander Degtyaryov and Vasily Khramushin, who will present.
Okay.
Sasha, you will present, yes?
Yes, but
Okay.
Okay, is it okay?
Okay.
No, it is not okay. You
It's not
see
yes.
full screen or not?
No.
Oh no. Okay, because I
We have
have
3
to.
minutes. We have 3 minutes, so you don't be nervous.
Okay.
Yes, I think.
Okay, now it is the full screen, yeah?
No, it's not full screen. I think it's you must slideshow. You must
Okay.
read slideshow.
Александр Борисович, альт-табом попробуйте переключиться на нужный.
Рестартом?
Альт-табом.
Альт-табом.
Альт-таб. Yes, not.
No.
Well, if you share the screen, you can change between the moderator view and the presenting view.
Sasha, start please. I think it's okay. We will see.
Now, can you click on presentation?
Давай, говори.
And yeah, in the upper you can change between the moderator. I think the icon who is in the middle, in the top of the page. I don't know Russian, so I cannot help you, but the button in the middle.
Он предлагает параметры отображения нажать и там выбрать экран.
Я думаю, так хорошо, мы все поймем, ничего страшного. Пусть текстом будет, даже удобнее. I think this is with the text is okay. This view.
Because here I have comments on the slide.
But it's okay. It's interesting for us also.
This one, can you see my screen? If you select here, you may change between the moderator view and the presentation.
It rejects me from the system when I try to.
Now it's okay.
Yes, it works.
Yes.
Now it's okay.
Yes.
You win. Wow.
Yes, I do it. Okay. Hello, everybody. I am very glad to present our report with my colleague Vasily Khramushin about it is a continuation of the series of our reports in at this conference last year, the year before, and this is a continuation of this our series of work that focused on virtual test bed. And here we focused on the one of the very important components of wave reflection at ship hull and how it is work in at our marine testbed. Here you see the outline of that with focused attention, and I will start from the same point as 2 years ago at the conference. What is the main idea of virtual testbed? I will repeat very briefly about it. This is an attempt to completely replace the real object and the environment in which it is located with its virtual counterpart. The ability to solve complex problems in very increasingly complete and close to the natural conditions formulation has led to the fact that the mathematical models have reached such a high degree of adequacy that they can often be used as a substitute for a physical experiment if the physics of the investigated phenomenon is fully understood. At that time, we presented our results in organization Marine Virtual Testbed. For these purposes, it is necessary to carry out two high-efficient models that can work jointly. The first model is the model of sea waves. There are well-known two types of models. First is looks like a Longe-Higgins model. It's at the high of the slide. And the second one based on autoregression middle average ARMA model. In many works, we have shown that ARMA model is more computationally effective. At the same time, it represents all physical phenomena of wind waves. Here you see the general, maybe it is a very complicated formula, but in computation, from the computational point of view, it is very fast and rather simple in realization. Algorithm of wind field generation, you can see at this slide. Here you see general algorithm, and with this algorithm we can simulate even the case of non-linear waves. And here you see an example of three-dimensional wave simulations. Such model allows to calculate hydrodynamic pressure in any points under the free surface at any time. This result took possibility to realize model of Fruit Krylov for calculation external forces and ship motion simulation. This approach and these results we presented before in many our reports and articles. And here you see the realization of ship motion by such approximation. This approach assumes that ship hull does not influence on pressure distribution under the wave surface. And such assumption is good in many cases, and two famous scientists, Alexei Krylov and Fruit, have shown at the end of 19th century that it works, and it's really covers from 60 up to 90% of accuracy. But wave reflection of ship hull can input error in final result. So for improvement of quality of ship motion simulation, we add component of pressure calculation taking into account waves reflection. Impact of waves reflection had the most effect for high nonlinear waves. So at the beginning, we consider limit waves and as example, Prahodo-Gerstner waves. Here you see the mathematical foundation of these waves, and you see the approach of Gerstner, which was presented a very long time ago, but still now it is very important, and maybe it does not used in a very strike or very good in calculations and the models, because it is rather complex for application. The problem of waves reflection from the ship hull requires more detailed accounting and consideration of dispersion properties of waves. Let us write out the necessary rates in the tensor form for the further process of direct numerical simulation. Here you see our approach and the formulas in our way of approximation and direct simulation, mathematical simulation that we presented many times. And if you are interested especially in this notation that you see at this slide, you can look at our works, one of which is mentioned at the slide at the bottom. It takes possibility, such application takes possibility to apply our approach for numerical simulation. And here you see the slide from the previous presentation when we explained computational aspect of virtual testbed. In our case, we again have three stages. Term of constant shift of coordinate system. It's a which is associated here with the first stage, kinematics. After that, the direct dependence from the velocity of environment, and at the end, inertial acceleration. Okay. I will not put attention more on this slide, because it is quite another, not quite another, but the basement which you can find in our previous papers and reports. And here you see the screenshot of virtual testbed in process of complex sea modeling. You here see the mixing of wind waves, swell, and the swell from the fast storm and more slight, but it's a swell with the lower frequency, mean frequency. And the ship dynamics here you also can find. Okay, next. And in result, we obtained the such picture, and here you see our principal result of the simulation. This is the moment when we see reflection on ship hull, and when the waves overlap through the ship deck. It was not possible in the previous results when we used just only the approximation on Fruit Krylov. It's new result in comparison with the previous our reports and our works. And here you see the virtual test bed as a scientific infrastructure for discover different ship qualities and design of the best variant of the hull. Now it is really can consider it and as a problem solution environment, scientific structure for the modeling and the discovering the ship dynamics and considering from the different sides without the very high cost model experiments, natural full-scale experiments, and so on. And of course, it takes possibility to reduce the time for design and the time and of course the finance for development. And in this case we joined this virtual test bed with some tools for naval engineering, and here you see the combination of results of virtual test beds with additional engineering tools. And the last, of course, and if we can see here, you see how we can change the. Here you see the one. The beginning of our of the process of the design, and here you see that we can obtain the most GZ curve for new shapes and choosing the optimal between them. And at the end, at the finalizing of my speech, I can show that in the conclusion 3 points that we can approach to. We presented the approach for the complex modeling. Now, in this case, our marine virtual test bed becomes more realistic, and the new result that we combine the new tools, and it opens the new direction in naval hydrodynamics for design of optimal ship forms. Here you see the freeware, which is developed by my colleague Vasily Khramushin, and any your questions will be welcome. Thank you very much.
Thank you, Sasha. And yes, please. questions, colleagues? So I have one question. Sasha, please explain, if you can, what are the conditions of appearing waves with extreme height? I think they are called waves murderers or wave assassinators.
As I understand well, it is you mean you mean the problems with the nonlinear waves and extreme waves, yeah?
Yes, yes.
Yes, here we especially consider the Gerstner wave, especially as an example of extreme nonlinear waves, because if we consider just only waves which are ordinary waves in the ocean, of course they are linear, and in this case it is possible to model them and without any problems. But here we consider the rate of wavelengths and wave height up to 1.15, 1.20. So it is very very near where it is near to the boundary when it became break. Of course, that's why it was necessary to consider and put the special maybe some heuristic formulas for dispersion ratio.
Okay, thank you. So any other questions?
May I ask?
Of course.
Of course.
The question is
Yeah.
the following. As I understand, it is these models are development time
Yes.
models. And can you use it as a runtime models?
Yes, yes, really.
And what are specifics?
Maybe Vasily can answer it more in more details, but I'll try. We have some problem solution environment when combine the computational in real time, and now we have some not problems, but we have some obstacles which related with lower power of processors, but now we are working in parallelization and mapping to the GPU, and it combined with visualization. So it in one environment. So now we have real time and maybe even in faster. So twice, 4 times, 5 times faster than in real time. So we can combine it.
Thank you.
So I think that was the last presentation. So our session is over. Thank you very much for cooperation, dear colleagues. Bye.
Goodbye.
Thank you. Bye.
Thank you. Bye.
Thank you.
Thank you. Bye.